Okay. All right. Okay, so what the first thing that we want to kind of do on this is look at what we call a rational exponent. Okay, this is something that you want to get real comfortable with in the class. So the idea is you've got this general formula right here. So if you have a to the m over n, like if you have a number with a fractional exponent, you can change it into a radical. A radical is just the generic word for square root, third root, fourth root, and so forth. What happens is the denominator of that exponent turns into the name of the root, and then the numerator just tells you what power that is. Okay, there was for a long time historically, people thought nonsense. Fractional exponent doesn't make any sense. And if you think about it, it really doesn't make a lot of sense. You know that 2 to the third just means you write something out 2 to 3 times. But if I say something like 16 to the 1/2, how do you write something out half times? That makes no sense. So for a long time, we thought, nonsense. Fractional exponents don't make any sense. Well, they do. They end up really being radicals. They end up being that idea. So the idea is if you have some number to a fractional exponent, you can work it out by changing it to a radical. So that's what I want to go through first of all. If you have 16 to the 1/2, what that really means is the denominator 2 tells you it's a second root, and that numerator 1 just tells you that 16 is the first power. Okay, so we basically want to know how to change these things over before we work them out. Okay, if I did the next one, and I'm not going to work them out yet, this would just be the second root of 27 to the first. This one would be the third root of 8 to the first. So you can flip over a fractional exponent into a radical. And then you can work them out, okay? So let's go ahead and work these out. Well, a second root is a square root. We don't ever put the second root on there. So square root of 16 would be 4. So 16 to the 1/2 power is going to be equal to 4. That's what that means. A 1/2 power means you're doing a square root, okay? So notice if I did this on my calculator, if I did 16 raised to the 1/2 power, well, the calculator knows what to do. It's doing a square root, okay? That's all it's doing, okay? The next one, if I did this on a calculator, if I did 27 to the 1/2 power, what your calculator is doing is it's doing the square root of 27, okay? I don't want that answer. I want a simplified radical like we've been doing quite a bit in class today. So you have the square root of 27. You have perfect squares like 4, 9, 16. How would you break up the 27? 9 times 3, right? 9 is a perfect square. So like we did a little bit in class today, we'd have 9 times the square root of 3. So what's the appropriate answer? 3 times the square root of 3, right? Okay. All right, so that's how you would simplify that expression. So what you notice, like on a calculator, 27 to the 1/2 power is really 5.196 with a bunch of decimals. Notice if I go 3 times the square root of 3, I'm going to get exactly the same thing. You can tell you're right by just throwing that in the calculator. But I'm looking for the simplified radical answer, okay? Okay, the next one is the third root of 8 to the first, so it's really the third root of 8. Well, a third root just means find a number you multiply out 3 times, it gives 8. So what is that? That's 2, okay? So sometimes these things turn out even, sometimes they don't. Okay, so a 1/3 power is the same thing as a third root. Okay, on your TI does any kind of radical you want it to do. So if you look at your math button, you're going to see that you have option 4 is a third root. Option 5 is an X root. It will do any root. So on this problem, if I just went down to option 4 and then put in the 8, it'll do a cube root for you. Okay? Yes. You okay? No. Okay, because what we're doing is you only get that plus minus if you're solving an equation. So if you have like x to the second equals 9, that equation has two answers because 3 to the second is 9 and negative 3 to the second is 9. When you do the act of square rooting both sides, then you get two answers. We're not solving an equation right now. We are simply working out a radical. That's why, okay? So it turns out that this really means, when you see square root of 16, it means give me the positive answer. Okay, if it was written this way, that would be telling you give me the negative answer. Okay, that's why you're thinking what you're thinking. Okay, all right. So let's move on to the next row here, and these things are the same thing. You want to be sure that you know how to change these over. So this one goes like this. You're going to have a third root of 64 to the second power. Now, you don't want to do 64 to the second on your calculator. It's a total waste of your time to do 64 to the second on your calculator, because you can write this way. You can write this as the third root of 64, then raise that to the second power. It's better to do it that way. Basically, these two things mean the same thing. Third root of 64 to the second is the same as the third root of 64, then to the second. It doesn't matter which order you do that. You can do the radical or you can do the exponent. Doesn't matter which order you do it in, you'll still get the same answer. Okay? Okay, so the cube root of 64. Maybe you can do that in your head. Can you think of a number you would multiply out 3 times that would give 64? That's 4. If you don't know, you're going to run into times when you're going to need to use your calculator. So again, if you go math, option 4 is where you find the cube root. And if you put in 64, that's going to give you 4. Okay? So you would end up getting 4 to the second power, which is 4 times 4, so that's equal to 16. Okay? So when you're working out problems like this, you want to do this by hand. You don't want to do homework like this. I mean, yeah, you could do 64 raised to the 2/3 power, and out is going to pop 16 like we just got. But if you do your work that way, you aren't going to learn anything. You're not going to learn what you're supposed to learn. You got to do this by hand and use your calculator more as a checking tool. Okay, is everybody with me there? Okay, all right, got a way to tell you're right though. Okay, this one goes like this. E goes like this. You have a second root of 81 to the third. Okay, do not waste your time doing 81 to the third on your calculator. It's not wrong to do it that way, but there's a better way. It's better to write this as the square root of 81, then to the third power. Do the square root, then the exponent in that order. The reason is because you can do it in your head. What's the square root of 81? 9. 9 to the third, I don't know if anybody knows that. I know it. It's 729. If you don't know it, get your calculator out. So if you just do 9 to the third, you're going to get 729. So that's the way that you would reason through that problem and figure out the answer. Okay, you're trying to learn how to change a fractional exponent to a radical. In my Calculus 1 class, we do this all the time. It's just a fundamental skill that you have to do when you're working with what we call a derivative in Calc 1. Okay, so this one, you have two choices. You could write this as the fourth root of 16 to the negative 5. There's not a thing wrong with starting it that way. You could also, and I think it's actually better to do it this way. So what did we talk about, I think, like the first week of the semester? What do you do with a negative exponent to change it into a positive exponent? You take it to the bottom, right? So the best first step is to write this like this. If you got a negative exponent, make it a positive exponent. We talked about that. That was one of the things I reviewed, right? Okay. Now change this to the fourth root of 16 to the fifth. Now write it this way, though. That way you can do the fourth root of 16, then you can raise that result to the fifth power. So I'm making the negative exponent positive, then I'm changing it to a radical, okay? So here's how you do a fourth root on a TI. If you want to do a fourth root, you have to put the 4 first, then you have to do the math button, then you have to go down to option 5 where it does the X root. If you do this on an 84, it'll automatically change it into a fourth root. So if you do the fourth root of 16, that's 2, because 2 multiplied out 4 times gives you 16. So this is going to give 1 over 2 to the 5th, and then you can work out 2 to the 5th on your calculator if you want to. That's 32. So you would end up getting 1 over 32. Okay? So you have to know these things: what to do with a negative exponent, how to change the fractional exponent to a radical, and how to work out the radicals. Okay? Are you guys understanding what I'm talking about here? It's very abstract, but this is how you work with fractional exponents. They are the same thing as roots. Yes?
Yeah, because I still don't understand how you got from 4 squared.
Okay, so back on D, what I did was I did this. Okay, the first thing, essential thing you have to know is this becomes the third root of 64 to the second. You have to put the numbers in the right place. Okay, but you can either do 64 to the second on your calculator and get that huge number, then do the cube root, or you can do this. It's easier to do the cube root of 64, then raise that result to the second power. The cube root of 64 is 4, because 4 times 4 times 4 is 64. Okay? And then 4 to the second is 4 times 4, so that's 16. So that's how I worked that out. Okay? That's the idea. You can do the radical before you do the exponent. Yeah, if I'm wanting you to show work and stuff, you have to at least write like this on there. You got to write how you're changing that to a radical. Then you can do some of the radical work with your calculator. But what you can't do is just 64 2/3 on the calculator. Whoopee, I got 16. Okay, you can't just do that. Okay, all right, very good. Okay, so you guys go ahead and work out the next 2 rows here. I don't think my counting's very good. I think it's supposed to go 5, 6, isn't it? Okay, so do the next 6 problems. Very similar. Try to do as much of them as you can without your calculator, and then we'll just see how well we're absorbing this idea here tonight. Okay, so let's see if we got everything okay on here. So the first one, you're really doing the second root of 100, okay, which is 10, right? Square root of 100 is 10. The second one, you're doing really the second root of 50. Now, you don't have to write that step. A square root is just written without the second, and of course, the first power is not necessary. So that's a decimal. So how did you break up the square root of 50? 25 times 2. Good. Okay, so you've got square root of 25 times square root of 2. And a lot of you did this backwards. A lot of you had 2 times the square root of 5. Well, which one comes out of the radical? That one. The square root of 25 is 5. Okay, it's a common misunderstanding that I see quite a bit. Okay, so that's good. Okay, next one, you have a negative exponent, so you're wise to change it to a positive exponent. Then change it over to a radical, so that's 1 over the fourth root of 81 to the first. Okay, well, the fourth root of 81 is 3. Why? Because 3 times 3 times 3 times 3 is going to give you 81. So the answer to that problem will work out to be 1/3. Okay, got a negative exponent, take care of that, and then change it over to a radical. Okay. Okay, this next one is third root of 1,000. It was interesting. I observed a lot of people weren't sure what that was without a calculator. Okay, well, that's okay. It's late at night, so what is it? 10. 10 times 10 is 100. 100 times 10 is 1,000. So that answer on that one is 10. Okay. What's that? Okay, the next one goes like this. You're going to have the third root of 27 to the 5th. Now, the way you do this is it's easier to do the third root of 27 then raise that to the 5th power. Okay? What? Just doing it in that order?
Learning it that way.
Oh, yeah, yeah. Yeah, because you don't want to do 27 to the 5th. No. You do it in the logical order. So the cube root of 27 is 3. 3 to the 5th? What is that? 243, right. And you do that on the calculator. That's 243. Okay? All right? And then this next one, you would have 1 over 32 to the 7/5. Get your exponent positive. And then write this. The best way to do this is do the 5th root of 32 and then raise it to the 7th. Okay? It's just a better order to do it that way. Okay? So this one would end up giving 1 over 2 to the 7th. And what's 2 to the 7th? 128, I think. You do it on the calculator. So that would give 1 over 128. Okay, that's it. Okay, so you guys did pretty good. Is there anything that you got a issue with on that? Okay, it's not too bad. Okay. All right, we're going to do the next page very fast. Okay, because it's just backwards. It's only doing it backwards. There's nothing to work out on this page. It's just doing this backwards. Okay. So this is what my calculus students do quite a bit. So if you have a square root, this would be 10 to the 1/2 power. Square roots are the same thing as a 1/2 power. Okay. The next one is 3rd root of x to the 1st. So what would that be? That would be x to the 1/3. We're doing everything in reverse of what we just did. Okay. So basically, the name of the radical is always the denominator. So on the next one, you would have x to the negative 3/4. That's perfectly acceptable to leave it that way. If I wanted you to change it to a positive exponent, what would you do? Move it to the bottom. Good. Okay, so that's all we're doing. We're not even working these out. We're just learning how to switch them from one form to the other. Okay, what would you do on the next one? 7 to the 11 over 6 power. Don't work it out. Just do that. Okay. Okay. And then the next one, how would that go? X to the 15 over 5. But what is that? X to the 3rd. You could go ahead and work out 15 divided by 5 and get x to the 3rd. Okay. So you can basically change these things back into that form like that then. Okay. So let's just do these together and then we'll be all done tonight. So what would be the answer on square root of 13? 13 to the 1/2. Okay. How about the next one? 10 to the 1/5. How about the next one? X to the 5/3. Good. How about the next one? Okay. And if I want it to be a positive exponent, what is it? 1 over 7 to the 3/8. Okay, like that. Okay. My calculus students do this all the time. Okay. And what's the next one? 18 over 9. So it's really x to the 2nd. Piece of cake, right? Okay. All right. So the reason we're learning that is because of a different type of equation that we'll do next Monday. Okay. All right.